Solve the following equations, they say, by completing the square. So if you try to factor these two, or if you try to factor this one, you will not get anywhere. You'll end up trying to find two numbers which add up to -8 and multiply to 10 if you're doing it by decomposition. And there's no such numbers, at least there's no such integers that can do it. So completing the square is what we try next. There's a coefficient on our x squared term, so we go after that first, and we factor it out of our first two terms. Leave some room. There's our +5, and it equals 0. Now, you take the -4, divide it by 2, and square it. The result is 4. There's two ways that you can handle that 4. Certainly we need to put a +4 here. Now, you can put your -8 out on this side, or you can put a +8 over on the right-hand side. You can either think of it as, I've added 8 here, therefore I must subtract 8 to keep things balanced. Or you can say, I've added 8 on the left side, therefore I must add 8 on the right side. It really doesn't matter which one you use. I don't even have a preference. I just kind of pick one of those methods randomly each time. I'll go with the +8 for this, just to show you that it works. So now, this expression we've made should factor very nicely, and it does. It becomes x minus 2 all squared, and then we have +5 equals 8. So now we want to solve this for x. That means we need to subtract 5 from each side. And divide by 2. Or 1.5 if you like decimals better. Square root both sides. Don't forget your plus or minus. And add 2. X is 2 plus or minus root 3 over 2. They didn't say what form they wanted these in, so I'm just going to stop right here. This is a perfectly reasonable way to give the answers. If they said give the answers to the nearest hundredth or whatever, then you would run this calculation twice. You'd do 2 plus root 3 over 2. That's one answer. And then 2 minus root 3 over 2 gives the other. Now, this is like the general case where they don't give us any numbers. We just have to work with these variables, which is going to be interesting. We'll follow the same steps, though. Nothing changes about the procedure. It's just going to be harder to do. We factor a out of the first two terms. Ax squared divided by a leaves x squared. Bx divided by a leaves b over a x. Or you could write bx over a if you wanted. Our c gets kicked outside, and then we have equals 0. Now, fractions start happening. If you take b over a, and you divide it by 2, that's the same as b over a times 1/2, so it becomes b over 2a. So we take this, we cut it in half, we get b over 2a, then we square it, and we get b squared over 4a squared. And wonderful news, we have to add that on the right-hand side as well. On the right side, we don't just have b squared over 4a squared, we also have to multiply it by this coefficient out front, so it gets multiplied by another a. That's probably the worst step in this whole thing, so hang in there. Now, this that we've just created is factorable, and it's going to factor as x plus, where would this come from? Its square root is b over 2a, and then that's all squared, and on the right side we get ab squared over 4a squared. Now, a over a, I can't resist that. I'm going to cancel an a on the numerator and an a in the denominator. That's more like it. Keep things as neat as we can. So, if we're trying to solve this for x, the next thing that happens is we divide both sides by a. So, divide by a over there. On the right side, I'll multiply by 1 over a. Huh. I could have waited and canceled the a's there, but oh well, this will work as well. A's on the left cancel out, and we get x plus b over 2a squared equals b squared over 4a squared. Looks pretty bad, doesn't it? It is, I'll grant you that. Just keep double checking all your work, make sure you're not making any mistakes, and just soldier on. We're getting closer. The next thing that has to come off is this square. So we square root the left side, square root the right side. And we get x plus b over 2a equals plus or minus. Now, here we catch a bit of a break. This actually has a square root. The square root of b squared is just b. The square root of 4a squared is 2a. So that's a huge improvement. And then we take this b over 2a over to the right-hand side. Oops. So follow along with what we did in the other side. When we got to this point, we subtracted the 5 from each side. Here, we're subtracting c from each side. So the next thing that happens is we have our a. Oh, and also in this line, we factored this expression. This is a trinomial, and it factors very nicely. The x squared would have come from x times x, and the b squared over 4a squared would have come from b over 2a. It's all squared. Now on the right we have ab squared over 4a squared, and we took the c over to the right, so now we have this. Now notice we have a over a squared here. We can't leave that alone. We can cancel an a in the numerator, cancel an a in the denominator. That's more like it. And to make this turn out the way I want, you don't automatically have to do this, but I'm going to make a common denominator on the right-hand side. You'll see in a minute this is a good thing to do. The denominator is 4a, so I'm going to multiply this by 4a. I'm going to multiply this by 4a. And in the next line I'll resolve all of this. So we have a times x plus b over 2a. It's all squared. And on the right we have b squared minus 4ac, and it's all over 4a. Now, that corresponds to this state in the original question. Next thing we did was divide by 2 on either side. So in our problem, we have to divide by a. Divide by a there. And on this side, I'll multiply by 1 over a, because we're in fraction form on the right. This is an easier way to handle it. On the left, the a's cancel out. And we're left with x plus b over 2a, all squared. On the right, we get b squared minus 4ac, all over. We have 4a times another a, which makes a grand total of 4a squared. So that corresponds to this step. We've got something squared equals a fraction on the right. What did we do next? We square rooted both sides. So root there, root there. On the left, we get x plus b over 2a. It's not squared anymore because the square and the square root killed each other. On the right, we get the square root of b squared minus 4ac. And the denominator, this actually has a square root. We can do this part. The square root of 4 is just 2. The square root of a squared is just a. And don't forget, when you do a square root on both sides like this, you get a plus or minus. Last thing that happens, here we took this negative 2 over to the right-hand side. Here we're going to take b over 2a over to the right-hand side. And so we get x equals minus b over 2a it got moved to the right side, so it went negative, plus or minus root b squared minus 4ac all over 2a. Now, we catch a break here. We have a common denominator, so we can squish these two pieces together. And when you do, you get minus b plus or minus root b squared minus 4ac all over 2a. You recognize that? This is the quadratic formula. It wasn't brought down from heaven by an archangel. You can make it yourself anytime you want to by taking this general trinomial and completing the square on it. What the quadratic formula does is just all of these steps that you would have to do to complete the square on a trinomial, except we haven't plugged in the numbers yet. We just give you this that says, here's every single step that completing the square would have done. We've compacted it all into a single equation. So, this will solve any quadratic for you, whether you can factor it or not. It does the same job as completing the square. Excellent thing to know. I hope you write it down, and I hope you memorize it.